Fatma, you're not in classroom yet. Uh, I've seen the other people there. Fatma, you are not there yet. Okay, so if you have to send me any messages during the class, please send them to the co-host account as usual, because that is what I will be looking at. Or you can also send message to everyone, and I can see that in the other window. Then, if don't send a private message, then just send to everyone so that I can see it on another account as well. All right, so let's begin. Can someone please confirm if you can see my screen?
Yes, we can.
Okay, all right, thank you. Okay, so this is what we started with in our last session. We talked about some very basic stuff. The different types of numbers. The more important thing from here was the difference between rational and irrational numbers. This in particular, that's what a lot of students get confused with sometimes. So that's what you need to focus on more here. Difference between rational and irrational numbers, and how to write down a rational number between some given numbers. Okay, should be able to do this. And then apart from this, this was an important point that 2 is considered a prime number. Okay. A lot of times students think that prime numbers have to be odd numbers necessarily. It's not necessary. 2 is an exception, right? The rest of all the other prime numbers are odd, because if it's an even number, it will be divisible by 2. But 2 is a prime number because it does satisfy the condition for prime numbers. And also 1 is neither prime nor a composite. Okay, so these were some important things. Then we started talking about fractions, and in fractions, we looked at how to add fractions, how to subtract fractions. Basically, we can only add or subtract fractions once we have the denominator is the same. Okay, so we need the denominator same to be able to add and subtract factors. That's what we talked about, how to make the denominators the same. One idea is to just multiply the denominators. That was one thing that we did. We just multiplied the denominators like this. And the other idea, a more efficient idea, is that you make the denominators the same in such a way such that the denominator is the LCM. So you find the LCM of the denominators. In this case, for instance, the lowest common multiple was 16. So how can we make the denominator 16 for both fractions? For the second fraction, it's already 16. For the first fraction, we multiplied and divided the numerator, multiplied and divided the fraction by 2. So we basically had multiplied by 2 in the numerator, and we also multiplied by 2 in the denominator, and that converted the fraction to a form that we had 16 in the denominator, and then we just added the fractions. Okay, so that's what we did. Now let's talk about how to do multiplication and division in fractions. That's really straightforward as well. Multiplication and division of fractions. Now, for now, we're talking about simple fractions, not the mixed fractions. Just simple fractions. How do we multiply them? So if we have, for instance, 3/7 multiplied by 6/5, How are these fractions going to be multiplied? We just multiply the corresponding numerators and denominators. Multiply the numerator with the numerator, multiply the denominator with denominator. So 3 times 6, what's that? That is 18. 7 times 5, what is that? That is 35. So you get 35 from this. That's how you do multiplication. Okay, fairly straightforward. Now, sometimes what happens is you have an integer. So for example, you could have 7 multiplied by 5 over 8. Now you're multiplying an integer with a fraction. Okay. Now, how do you do this multiplication? 7 is only going to be multiplied with the numerator. It's not going to be multiplied with the denominator. Okay. So 7 only gets multiplied by 5, and that gives you 35 over 8. In order to avoid this mistake, you can also avoid the mistake of multiplying 7 by 8 as well. You can also think of 7 as 7 over 1. Okay. So 7 over 1, the numerator gets multiplied with the numerator, the denominator gets multiplied with the denominator, and you get the result. Okay. But remember, if integer is multiplying, that will only multiply with the numerator. Okay. Now, this is for numbers. It will work the same way for any algebraic expressions as well. So for instance, if you've got 6 times x plus 5 divided by 3x minus 2. Now, the 6 is only going to get multiplied with the numerator and not the denominator. So it will be 6 multiplied by this whole thing. So it's a better way of writing this could be using brackets. So 6 multiplies only with the numerator, and that gives you 6 times x plus 6 times 50, 6 times 5, which is 30, 6x plus 30 divided by 3x minus 2. And that's the fraction that we get as a result of this. Okay, fairly straightforward stuff. You multiply the numerator with numerator, denominator with denominator. If it's just a single number, an integer, that gets multiplied with the numerator only. What about division? If you've got a division problem, for example, if you want to do 3 over 7 divided by 2 over 5, how is this going to work? You basically convert it to a multiplication problem like this. If you change this division sign to a multiplication sign, you can do reciprocal of this. So 2 over 5, you will write that as 5 over 2. And that is going to give you the result, which is 15 over 14. Okay, so if you're dividing two fractions, you change the division to multiplication, but then you have to change it to the reciprocal. And then you can multiply the numerator with numerator and denominator with denominator, and you get a result. Okay. Now, sometimes you can end up getting fractions inside fraction. So for instance, you could have, now this is very important. A lot of people make mistakes in this, even when they go to their A levels. So you should be very clear about this. Let's say you've got a number like this. So let's start with two fractions. So let's say you have 5 over 6 divided by 2 over 3. You want to do this division. Okay. An easier way that will save you from careless errors of simplifying this would be that you write it separately like this. 5 over 6 divided by 2 over 3, you write it as 5 over 6 with a division sign. So instead of this fraction here, you use a division sign and you say it's 5 over 6 divided by 2 over 3. And then you convert it to a multiplication thing. So it becomes 5 over 6 into 3 over 2. And now you can just multiply these numbers directly. You can do some cancellation as well if you want. For instance, in this case, 3 and 6, they get cancelled when you have 2. And in the numerator, you just have 5 left now. And in the denominator, you've got 2 times 2, which is 4. And that gives you 5 over 4. Okay. Now, if you have something like this instead, 3 divided by 5/7. Now, notice, where is the bigger fraction? Where's the bigger fraction sign? This is the bigger fraction sign, right? 3/5/7. How are you going to simplify this? In fact, what I'm going to do is I'm going to let you try this first. So let's say we want to simplify this. And at the same time, we also want to simplify this 3/5 divided by 7. Can you give me the answers for both of them quickly in the chat box? Very quickly. The first one and the second one. What do both of them simplify to? Quickly. These will just be 1 mark problems. So you should be quick about them. What do we get? The first one. I want all of you to respond. Please, in the chat box, everyone. Send your messages to the co-host account or just to everyone. What do we get from the first fraction? And what do we get from the second fraction? So the first one, this gives us 3 divided by 5/7, right? And then we can write this as 3 into 7/5, and that gives us 21/5. That's the first one. And what about the second one? This is different. This is going to be 3/5 divided by 7, and that gives us 3/5 multiplied by, this is division by 7, right? So that becomes 1/7, and that is 3/35. Okay, so this is an easy way of doing this, although it takes slightly longer, but this is how you can do it. This is the logical way of doing this. You can also do it directly. Let me explain to you how that is going to work. So if you have A over B divided by C over D, A over B divided by C over D. So we've got fractions like these. What happens is the denominators of both fractions, we can take them above or down. So this B can go down and get multiplied with C, and this D can go up and get multiplied with A. So you can directly simplify this as A times D divided by B times C. A gets multiplied with D and B gets multiplied with C in the denominator. Another way that people kind of remember this is that you have number 1, number 2, number 3, number 4. What happens is number 1 gets multiplied with number 4 in the numerator, and number 2 gets multiplied with number 3 in the denominator. Okay, now the logic of this is the same as before. So you've got A over B over C over D. You can write this as A over B divided by C over D, and then that becomes A over B into D over C, and that's the same thing as AD over BC. So what you can think of in your head is this denominator is going to go here, and this denominator is going to go here. So that gives you AD over BC. Okay, you can remember this directly as well. Do some practice with this, and this makes things quicker. You don't have to write all of that up. Okay. Similarly, if you have A over B whole over C, this denominator can go here, and that is going to give you A over BC. Right? So for instance, if you've got 2/3 divided by 5, this denominator can go to the denominator here, and that gives us 2 over 3 times 5, which is 2 over 15. Okay, you can do it slightly quicker this way. Similarly, if you had a over b over c, the denominators can go to the other side, right? So this denominator is going to go above. So it becomes ac over b. For instance, if you had 7 over 2 over 3, this denominator will go to the other side, and that is going to give you 7 times 3 divided by 2, and that's 21 over 2. Okay, so you can do it slightly quicker if you just remember these rules, that the denominators can basically go to the other side of the fraction. Okay, so this b can go down, this c can go up, and in a general fraction like this b can go down here, and this d can go up here. Okay, so the denominators can go on the other side of the fraction, on the other side of the bigger fraction. Okay, I hope that makes sense. Any quick questions on this? If you get confused with this, and an easier, although slightly longer way of doing this would be to just write it down like this, and then you simplify that. But that will save you from careless errors in case you get confused with this. Okay, all right. So that's how we deal with multiplication and division. Now, in fractions, you also sometimes have mixed fractions. In fact, not sometimes, you have to deal with mixed fractions a lot of times. Now, what are mixed fractions? Basically, there are two types of fractions that we have. First of all, there are two categories that we have for fractions. One are proper fractions, and the other is improper fractions. Okay, so we've got these two types of fractions: proper and improper. Now, what are proper fractions? Proper fractions are fractions like these: 3 over 5, 4 over 9, 2 over 7. And improper fractions are fractions like these: 10 over 7, 11 over 3, 21 over 17, for instance. Now, what's the difference between these two types of fractions? Do you notice the difference? In proper fractions, the numerators are smaller than the denominator. And in improper fractions, the numerators are bigger than the denominators. Okay, so what is a proper fraction? A proper fraction is one in which the numerator is less than the denominator. And an improper fraction is one in which the numerator is greater than the denominator. Okay, that's the rule for fractions involving numbers. If the numerator and denominator are equal, that will be an integer. For example, if you have 6 over 6, that's just 1. In fact, whenever the numerator and denominator are equal, that's always 1. But otherwise, apart from that, if the numerator is bigger, that's an improper fraction. If the numerator is smaller, that's a proper fraction. Now, a lot of times, we prefer writing improper fractions in another form, and that's called mixed form, mixed fraction. Okay, proper fractions we leave as they are. We can actually not convert them to mixed fractions. We can actually, although that would look weird like this, we don't generally do that. Proper fractions, we write them as they are, but improper fractions are often written as mixed fractions. Now, how does that work? Let's take an example of that. Let's say you have a mixed fraction. You have an improper fraction like this. Recording. Okay. You have an improper fraction like this, 10 over 7. We want to convert it to a mixed fraction. Okay. This is an improper fraction. We want to convert it to an improper fraction. Improper fraction looks like this, that you have a fraction, and then you have another number on the side of it like this. Okay? Now, how do you convert it to this form? You have to do it using division, right? Division process that you've learned in earlier grades, I think 6th, 7th grade at some point. How do you divide 10 by 7? This is how it's going to work. 10 divided by 7. What can you multiply 7 by to get the largest possible number that is equal to or less than 10? You can just multiply it by 1, and that will give you 7 here. You find their difference, 10 minus 7, and you get 3 as the result. Now, this number that you have at the bottom, this is called the remainder. Okay? This number is called the remainder. The number that you have on top, this number is called the quotient. And the number that you're dividing by, this number is called the divisor. Okay? The number on top, that's the quotient. The number at the bottom, this is called the remainder, what you're left with after division. And the number that you're dividing by, you're dividing 10 by 7, right? So 7 is called the divisor. We have this rule that whenever we divide something by something else, so divide a number by something, after this division process, we can write it like this, that such that we have quotient here, divisor here, remainder here, and divisor here. Let me write it a bit bigger. So we can write it in this form such that we have the quotient here. So this number is here. Remainder is in the numerator, and divisor is in the denominator. So QRD, like this. Okay? So 10 over 7, therefore, can be written as quotient, which is 1, that's coming from here. Remainder, which is 3, that is coming from here. Divided by the divisor, and that is coming from here. We can write this as an improper fraction like this. Okay, you should be able to do this. You should be able to convert mixed fractions to improper fractions. Okay, so the quotient goes here, remainder goes here, and the divisor goes in the denominator. So denominator remains the same. Just remember that denominator is not going to change. On the left side, you will have the quotient. On top, you'll have the remainder. Okay? All right. So you should be able to convert improper form to mixed form. Now, you should also be able to do it the other way around. So you should be able to convert an improper form to mixed form. Sorry, mixed form to improper form. So for instance, if you have something like this, 3 whole 2 over 7, this is a mixed fraction. Okay, this is called a mixed fraction. This is called an improper fraction, as we discussed before. This is the mixed fraction. Now we have a mixed fraction. How do we convert this mixed fraction to an improper fraction? Now, this is what we do for this. We multiply these two numbers, 3 times 7, and then add the numerator. Denominator is going to remain the same. That is not going to change, as it does not change the other way around as well. 7, the denominator, that is going to remain the same. You're going to multiply 3 by 7, and that will give you something. 2 to that. So that's 21 plus 2, and that gives you 23. This is what you get when you convert to an improper fraction. So you should be able to do both conversions. Generally, when you're adding fractions, subtracting fractions, multiplying or dividing fractions, it's easier to do it in improper form. So generally, you will only use improper form sometimes in the final answers. When the examiner asks you to give your final answer as a mixed fraction, then you would convert to mixed fraction. Or they will give you a mixed fraction in the question itself, and in order to do multiplication or addition subtraction, you will first convert it to improper fraction. So these conversions are important, but addition, subtraction, multiplication, division, you will do all of that stuff once you have the fraction converted to this form. Okay. So if you have mixed form, you first of all convert to this form, improper form, and then you do and you apply any operations on that. All right. Okay. Now, there's just one more thing that you need to know about fractions at this point, and that is that sometimes you have decimals in fractions as well. So, for instance, you might end up getting something like this: 7.5 divided by 10. Now, this is a fraction. Generally, you cannot leave this as a final answer in the exam, because this is not the proper way, not the formal way of writing fractions. Generally, we don't want decimals in fractions. Okay. Now, how do you get rid of these decimals? You think of what you can multiply this decimal by to get an integer value. 7.5. What can you multiply a decimal with to make this an integer? It's 7.5, right? You can multiply this by 2. 7.5 times 2 is going to make it an integer. So you just multiply it by 2, but you can't just multiply the numerator by 2 because it will change the fraction. To balance that, you also have to apply the same operation in the denominator. So you multiply the denominator by 2 as well, and that will convert it to 15 over 20. And then you can simplify this. When you simplify this after canceling, it turns out to be 3 over 4, and that is the correct way of writing this as a final answer. Do not leave your answers in a way where you have decimals in fractions. Okay, so if you have a decimal, multiply it by some number so that that decimal is, you can get rid of that decimal. For instance, if you have something like this, 2.25 divided by 8. Now this is another fraction that we've got, right? We've got 2.25 in the numerator. How do we get rid of that decimal from the numerator? We have 0.25. What can you multiply 0.25 by to get an integer? You can multiply 0.25 by 4, right? That should give you an integer. So that's what you do. Multiply the numerator by 4. But to balance that now, you will also have to apply the same operation on the denominator. 2.25 times 4. We'll talk about decimal multiplication in a moment, but how do you think of it in your head? So let's do it this way. 2 times 4, what's that? That is 8. Then add to that 0.25 times 4. 0.25 times 4. 0.25 times 1 is 0.25. 0.25 times 2 is 0.5. And then 0.75. And then 1.0, right? So it will turn out to be 9. 8 plus 1, that's 9 in total. If your mental math is good, generally you'll be able to do it directly like this. If not, you can do it by writing it down, and that's perfectly okay. It does not take that much time. And in paper one, or in the non-calculator paper that you have, generally time is not going to be that much of an issue. You should be able to complete that in time fairly easily. So you should avoid doing careless errors. If you're unsure, write do the multiplication by writing it down. So you'll do it. So we'll talk about decimal multiplication in a moment. So if you multiply and divide by 4, what do you get? You get 9 over 32. And then you can see if you can simplify this further, which you can't. This is the final result. That's 9 over 32. Okay, somebody was saying something? Any problems? Any questions at this point? Any questions, anyone? No? All right. Now let's talk about decimals. How to do decimal addition, subtraction, multiplication, division. Now, of course, you've done the simple addition, subtraction rules and the multiplication, division rules in earlier classes already. So you know the proper way of doing this by writing everything down, right? Doing that whole multiplication process, carrying things, and then putting the decimal. But let's discuss some slightly more efficient ways of doing the addition and subtraction thing rather than doing that whole process of multiplication and long division. Okay. Now let's think about this. Decimals. Okay. Let's say you're asked to add something like this 6.75 plus 2.13. Now, this is relatively straightforward to do because both of the numbers have the same number of decimal places, right? So what you do is you write them one over the other like this. 6.75, 2.13. The decimals are aligning like this, right? So in order to be able to add and subtract decimals, the decimals should be aligned like this. And then you do normal addition like you normally do. 5 plus 3, that is 8. 7 plus 1 is also 8. And 6 plus 2 is 8. And you have the decimal at the same place. That's 8.88. Okay, now in this case, we had the same number of decimal places in both of them. However, if you have something like this, in which the number of decimal places is not the same. What do you do in that case? For example, if you have 7.23 minus 6.5. Now, what about this? When you do this subtraction, be careful how you write it down. 7.23 minus 6.5. Now, don't write it randomly like this. The decimals have to be aligned. You cannot do it like this. The decimals have to be aligned. So this decimal has to be here, and then 6 is on the left side, 5 is here. So this 5 corresponds to this 2. 2 and 5, the first decimal places should be aligned, the second decimal places should be aligned, and the decimal itself should be aligned like this. And then you can do addition subtraction. So how will it work after this? Once you've placed it like this, you do it like you normally do any addition subtraction problem. You can add a 0 here, like so if you want, or you can just take 3 down as it is. That's your choice. It doesn't really matter. Now, 3 can come down like this as it is. 2 minus 5, can you do that? You cannot do that. So you take 1 from here and you get 12 minus 5, and that will give you 7. Now, since you've already taken 1 from here, you're just left with 6 here in place of 7. 6 minus 6, what's that? That is 0. 0.73, that is your final result. Okay, let's try another very quickly. Let's say you've got something like this. You have 2.7 minus 1.3, or let's say minus, let me use a bigger number here now. Let's say you've got 12.7 minus 9.35. Okay, how is this going to work? Again, you have to make sure that the decimals are aligned, 12.7. And now when you write down the second number, write down the decimal first. When one number to the left of that, 9, and then the numbers to the right, 3 and 5. Okay, they should be properly aligned, and then you can do the addition subtraction. Now, there's no number above 5 here. You can write 0, right, to make things simpler to understand. And now you cannot do 0 minus 5. So what you do is you take 1 from here. So that becomes 1, 0. 10 minus 5, what's that? That is 5. And now you're left with 6 here. 6 minus 3, that is 3. And then again, you cannot do 2 minus 9. So you take 1 here. You're left with 0 there. 12 minus 9, that is going to give you 3. So you get 3.35 from this. So what you need to remember here is when you're doing addition and subtraction, these decimal places, they have to be aligned. That's the important part. The rest, I'm sure you're comfortable with addition and subtraction already. But when you're doing decimal addition subtraction, make sure that the decimals are aligned like this. Okay. Now, what about multiplication and division? That's where a lot of people end up making careless errors. Let's think about that now. What if you have to multiply or divide decimals? Let's think about multiplication. Let's say you've got two decimal numbers like this, 5.1, or let's take smaller numbers first. Let's say you've got 2.1 multiplied by 0.37. Now, how do you multiply these two numbers? Or let me actually make it even easier. Let's say 35. 2.1 into 0.35. We want to multiply these two decimals. Now, one way to do this would be you do it like you properly multiply any decimals like you've learned before, putting the decimal place in the right place. But that whole process is prone to errors. A lot of people end up making decimal errors there. They put the decimal place and the decimal at the wrong place. I would recommend you convert this to integers. Okay. Now, how can you do that? These are decimals. How do you convert them to integers? 2.1, you can write that as 21 over 10, right? You can write that as 21 over 10 because 21 over 10, you have 1 0 here, that will give you 2.1, right? So basically, you write it as a fraction in such a way, whatever is the number of decimal places. So how many decimal places do we have here? You've got one decimal place here. How many decimal places do you have here? You've got two decimal places. So when you convert it to fractions, whatever is the number of decimal places, you have that many zeros here. So you've got one decimal place, you've got 1 0 here. And 0.35, what will that become? You can write that as 35 over 100. You had two decimal places here. You have two zeros here with 1. So it becomes 35 over 100. And now instead of doing decimal multiplication, we can just do integer multiplication, 21 times 35. Do that multiplication and then divide by 1000 like this. Let's do that. 35 into 21. How do you think about that? We will, at some point later on, we will spend some time learning some mental math techniques as well. I would actually recommend you to listen to this guy, to watch this guy's videos at some in your free time if you have it at some point. But I will be discussing some of these tricks in one of our later classes as well. But until we do that, I would recommend to search for this guy on YouTube. And he shares some really nice mental math techniques that you can use to multiply numbers in your head fairly quickly, add numbers, subtract numbers in your head very quickly. For now, let's just focus on this. 21 times 35. How do you do that? A quick way of doing this would be you do 35 times 20, right? 35 times 20. What's that? That's easy, right? 35 times 20. 35 times 2 is 70. But then you have another 0 here. So that's 700. Okay. So you multiplied it by 20. You had to multiply it by 21, right? So you add another 35 to it. And that gives you 735. So this becomes 735 over 1000. If this is a bit too much for you, just do normal multiplication. That's perfectly okay as well. And that will be basically writing it down like this, 21 times 35. And then the way you multiply 5 by 1 and then 5 by 2, and then the next line multiply 3 by 1, 3 by 2, and then add the stuff together. You can do that. That's perfectly okay. But if you are someone who likes doing things mentally quicker, this is one way to think about this. You had to multiply 35 by 21. What you do is you do 35 times 20. Once you're done with that, add another 35 to that, right? So that gives you 735. And now, how do you convert it to decimals? You've got 3 zeros. You need to have 3 decimals when you simplify this. So this is going to become 1, 2, 3. That's 0.735. That's the result that you get from this. Okay, this is how we can do decimal multiplication. Let's take another example. Let's say you've got 7.52, or in fact, we had 1 and 2 decimal places here. Let's try an integer now. Let's say we've got 7 times 5.1. Now, how do we do this multiplication? 7 into 5.1. Now, 7 is already an integer. There's no decimal there. We can keep 7 as it is. Okay. What about 5.1? How many decimal places is that? That's 1 decimal place. We can write that as 51 over 10 with a single 0, right? We can write 5.1 like this. Now we just do this multiplication, 51 times 7. How is that going to work? You can multiply 7 by 50. Again, one way to do this is using standard multiplication. You can do that. If you were to do it quicker, you could do 7 times 50, right? Break it down like this. 7 times 50, let's do that first. And then 7 times 1, do that separately. What's 7 times 50? 7 into 5 is 35, so that's 350. 7 times 1 is a 7. 350 plus 7, that's 357. So this results in 357 divided by 10, and that's 35.7. That's the result that you get from this. Okay, so that makes decimal multiplication relatively easier to do. Let's take another example. Let's say you've got 3.6 multiplied by 2, or let's say 0.072. Let's say I have to do this multiplication. How do you do this now? Again, let's convert these two fractions. 3.6. What can you write 3.6 as? It's 1 decimal place, right? You can write this as 36 over 10 multiplied by 0.072. How many decimal places is that? That is 3 decimal places. So you can say 0.72 divided by 1,000. Now, it's not necessary to put a 0 there. You can just do 72 over 1,000. Okay. Now you've got integer multiplication to do. Do this multiplication, 36 into 72. Now, again, you can break it down into 2 parts if you want, or just do it directly using normal multiplication. In this case, they're both going to be almost the same level of effort. If you do 36 times 72, 2 times 6 is 12. Or you have to do it the other way as well. This way you already know. So what you can do is, to make it slightly simpler, you could break it into 2 parts like this. 36 times 70, do this separately. And then 36 times 2, do this separately. And then add them up together. Okay. 36 times 7, what's that? 36 times 5 is 180. Okay. And then 180 plus 36 times 2, that is 72. 180, 72. This will result in 252 and then 0. 2,520. That is what I'm going to get from this. Okay. And then 36 times 2, if you do that separately, that is 72. Add these two up together, you get 2592, and that's the final result that you're getting in the numerator here. 2592 divided by 1000. And now you can put those decimals there and see what that turns out to be. How many zeros do we have here? We've got 3 zeros. So we want 3 decimal places in our final result. So it'll become 2.592. That is our final answer. This is as difficult as it could possibly get in the exam. This is what you can do here as far as decimal multiplication is concerned, right? These were bigger numbers. Mostly you get smaller numbers than this, which are easier to multiply than what we did here, okay? But this is the way you could approach this. Convert them to integers by dividing by 10, 100, 1000, like that. And then you get your results like this, okay? Now, what about division? What about division? If you had to divide decimals, let's see how that might work. Let's take an example. Let's say we have 2.4 divided by 0.3. Now, in this case, we've got the same number of decimals, right? Numerator is the same number of decimals. Denominator, numerator is 1 decimal place. Denominator is also 1 decimal place. Rather than trying to divide 2.4 by 0.3, again, you can try to convert it to integers. How would that work? 1 decimal place, if you multiply this by 10, that becomes an integer. But you can't just multiply the numerator by 10. You have to do the same thing with the denominator to balance that, so that this fraction is simplified to 24 over 3. And 24 over 3 is easy to do now. That is just 8. And that is the final result. So the trick to do decimal multiplication and decimal division is to not do decimal multiplication and decimal division, convert that to integers. And that makes things simpler to do. Okay, let's take another example. Let's say we've got something like this. You have, this was 1 decimal. Let's say we've got something else now. 7.3 divided by, let's say, or let me use another letter here, another number. Let's just, you got 7.2 divided by 6. Now, how do we do this? We need to convert the decimal to an integer. We've got 7.2 in the numerator, right? How do we convert this to an integer? We can multiply by 10. Now we can multiply this by 10. We have to do that same thing with the denominator as well. Okay, so it becomes 7.2 times 10 divided by 6 times 10. And what does that give you? That gives you 72 divided by 60. And now this is something that you can do cancellation on. 6 times 10 is, in fact, 12 times 5 is 60, and 12 times 6 is 72. So this simplifies to 6 over 5. Okay. Now, how do you know we have to multiply by 10 here? So whichever decimal has the most number of decimal places, think about that, how to convert that to an integer. So this was the most number of decimal places, right? 0.2. How do you convert that to an integer? You multiply that by 10. Or sometimes people also think of it this way, that you have 6 in the denominator, make it the same number of decimal places. So you've got 6, you can write 6 as 6.0. And then you think of removing the decimal. How do you do that? You multiply by 10. Okay, let's take another example. Let's say we've got something like this. We want to divide. Let's say we want to divide 1.88 divided by 2.4. Let's say we want to do this division. Now, how is this going to work? Now, the numerator has how many decimal places? 2 decimal places. The denominator has 1 decimal place. You can make the denominator the same number of decimal places as well, just to make the thinking process slightly easier. Make it easier to think of. So you can add another decimal here if you want. Okay. And then how do you convert it to integers? You have two decimals. You have to multiply it by 100 to get rid of those decimals, right? You need two zeros to get rid of those decimals. So you've got 100 here. And now since you're doing that with the numerator, you have to do the same thing with the denominator as well to balance things out, right? You can't just multiply one of the numerator or the denominator. You have to multiply both things. What do you get from this? 188 divided by 240. And now you can do simplification of this. You can do cancellation. Are they both divisible by 4? Yes, they're both divisible by 4. You can see 240 over 4. That's going to give you 60. 188 over 4. How do you do this? 18. First divide 18. Okay. 4 times 4 is 16. So you can have a 4 here. But when you divide by 16, what number are you left with here? You're left with 2. So 28. 4 times 7 is 28. So you have 7 here. So that gives you your simplified fraction, which is 47 over 60. Okay, if you find it difficult to do, you can at least check that the numbers are divisible by 4, right? 24 over 4 is 6. That's kind of easy to do. What about the numerator? 100 is divisible by 4, right? So that's done. What about 88? 8 is divisible. This 8 is also divisible. So the number is divisible. Once you understand that the number is divisible, you can do the division process separately as well by writing it down, and that's perfectly okay. You can write it down like this. 4 times 4 gives you 16, and then you have 2 remainder, and then you bring down 8 as it is. You get 4 times 7, that is 28, and that's 0. Now, some of you with some practice will be able to do it in your head as well. That's what I was doing here, that I looked at 18 first of all, just like I looked at 18 here, that what can I multiply 4 by to get a number that's equal or slightly less than 18? I can multiply it by 4. So that's why I got 4 here. Now 16 and 18, I have 2 left. So that gives me this number 28. And then you can think in your head, okay, 4 times 7 is 28. So you have 7 here on top. Okay. If you are able to do it mentally like this, that's great. If not, it's perfectly fine to write it down like this. Again, it's not going to take that much time. It's better to be safe than sorry. You should write it down and not do any careless errors. Okay, so that's how the division process works. Okay, that's how we can divide fractions. Okay, now this was about decimals. Sometimes you have to divide fractions and give your answer as a decimal. Okay, sometimes you have to divide fractions and give your answer as a decimal. Now, how does that work? So, for instance, if you've got something like this, 35 over 50. Now, this is the fraction. We want to give our answer as a decimal. How do you convert fractions to decimals? Now, it's sometimes going to be easy to do. Sometimes it's going to take a bit more work. First of all, actually, let's do a couple of simpler examples. Let's say you just want to do 37 over 10, right? So you've got 37 over 10. You can easily convert that to a decimal, right? Dividing by 10, that gives you 3.7. So the number of zeros that you have, that's the number of decimal places that you're going to get there. If you have, for instance, 58 over 100, how many decimal places, how many zeros do we have in the denominator? 2 zeros, you're going to have 2 decimal places there. So 1 and 2, this is where the decimal is going to come, and that's 0.58. Okay. Now, both of these divisions were simple. Why? Because the denominator was 10 and 100, right? Now, the division is generally going to be easier when the denominator is something like this, when it's some power of 10, 10, 100, 1000, 10,000. When you have these numbers in the denominator, then the division becomes simpler. Okay. And that's the trick that we are going to use when we are dividing any other fractions as well. What we will do is we will try to convert the fractions to a form such that we end up getting 10 or 100 or 1000 in the denominator. So convert them to forms in which you get 10, 100, 1000 in the denominator. That's what we want. Okay. So for instance, you've got 35 over 50. Now this can actually be just cancelled out because 5 times 7 is 35 and 5 times 10 is 50, and that simplifies to 7 over 10, and you have 10 in the denominator. Now 7 over 10, we can write that as 0.7. Okay. What if we had something else? Let's say we had 4 over 25. Now we want to figure out what this number is, 4 over 25. How do we do this? This is 25 in the denominator. What do we want to convert it to? 10, 100, 1000, right? Something similar to that to those numbers. Now 25 is a factor of 100. What if we multiply 25 to get 25 by to get 4 to get 100? So what I can do is I can multiply the denominator by 4. But again, as we have been doing before, we can't just multiply only the denominator or only the numerator. If you're multiplying the denominator by 4 to balance that, we also have to multiply the numerator by the same number. So this fraction therefore can be converted to 16 over 100. And now that's easy to do. 16 over 100. You've got 2 zeros in the denominator, so you should have 2 decimals. That's 0.16. That's the result of 4 over 25. Okay. And similarly, if you have any other similar numbers, similar problems like these, let's say you've got 7 over 50. Or let me actually use maybe a bigger number. Let's just 7 over 125. How do we evaluate this now? 7 over 125. Again, the idea is we want to convert the denominator to what? A form like this. We want the fraction to be of this form. Something over 10. Something over 100. Something over 1000. Because then this division is going to be fairly easy to do once we have it in that form. Okay. 7 over 125. Now it's already bigger than 100. Can we convert it to one of these decimals? It could be bigger than this as well, but generally you don't need to do something bigger than 1000. 125. What's 125 times 2? 250. 125 times 4 is 500. 125 times 8, therefore, is going to give you 1000. So what you can do is, if you multiply the denominator by 8, that makes the denominator 1000. Now, you can't just divide only the denominator. You have to balance that by you can't just multiply the denominator by 8. You have to balance that by multiplying the numerator by 8 as well. So 7 times 8, what does that give you? That is 56. 56 over 1000. How many decimals do you need? You've got 3 zeros, so you want 3 decimals, 1, 2, and then another 1. So you need to add a 0 there. So it becomes 0.056. That's the result that we're going to get from this 0.056. That's the final answer that we have. Okay. Does that make sense? Any questions on this? Any problems? So this is going to be important. Converting the fraction to a form such that you have numbers like these in the denominator. Okay. All right. Now, one more thing on fractions. There are some divisions that you have to do a lot, like dividing by 2, for instance. A lot of times you have to find midpoints in which you have to divide by 2. You have to find a number that is in the middle of two numbers. You have to divide by 2 there as well. Now, how is that going to work? Let's understand that. So let's say we want to divide 52 by 2. Now, that's, in fact, let me make it, okay, I'll keep 52 over 2 written here. But let me do a simple example. First, let's say you have to do 42 over 2. Now, how is this going to work? 42 over 2. If both are even numbers, you can actually do it directly. How do you do that? You divide them individually. What's 4 by 2? 4 by 2 is 2. What's 2 by 2? That is 1. This is going to give you 21. So if both are even numbers, this division is going to be fairly straightforward like this. Let me write down a few more as well. Let's say you've got 84 divided by 2. What do you get from that? 8 divided by 2 is 4. 4 divided by 2 is 2. You get 42 from that. Okay. However, so this can actually be extended to 3 decimal places as well. Sorry, three digits as well. For example, you could have something like this: 684 divided by 2. All of them are even numbers. How do you do that? 6 over 2 is 3, 8 over 2 is 4, 4 over 2 is 2, and you get 342 directly. Okay, so if all of them are even numbers, this is going to be fairly straightforward to do. But what if they're not? What if you've got something else? You've got 52, for instance. How is this going to work? Now, you can do that division process in your head for this. 5 over 2, you cannot divide 5 by 2, but you can divide 4 by 2, right? Divide 4 by 2 first. What does that give you? 4 over 2. So let me actually write it down here. 4 over 2 is going to give you 2. But then you're left with 1 from here, right? So you have 12 left. So if you've taken 4 out of 5, you're left with 1 there, right? So 1 with this 2, now you've got 12 left. What is 12 over 2? 12 over 2 is going to give you 6, so that's 26. Okay. If you have any other number like this, an even number in which the other number is odd, how do you do that? Let's say you've got 76. You want to divide this by 2. You can't divide 7 by 2, but you can divide 6 by 2, right? So 6 over 2, what's that? That is 3. But then you have 1 left here. 16 over 2, what's that? That is 8. So that's 38. So even numbers are going to be easier to divide like this. But once you know how to divide the even numbers, then the odd numbers are also fairly straightforward, because you can just add a 0.5 to them. Now, what do I mean? What do I mean by that? Let's say I've got something like this. I want to divide 79 by 2. Now, this is in odd number, right? We cannot really divide 79 by 2. We cannot get an even number. We cannot get an integer answer from this. It's not divisible by 2. Now, how can we do it mentally? Again, because the calculator is not going to be allowed in one of the papers. How do you do this non-calculator paper? Instead of dividing 79 by 2, what you do is you break it down into two parts. You say, okay, I'm going to do 78 over 2 plus 1 over 2. Okay. So break it down like this. Take the smaller number from this. It's 79 over 2, right? So you just do 78 over 2. What's 78 over 2? 6 over 2 is 3, and then 18 over 2 is 9. That's 39. What's 1 over 2? 1 over 2 is just 0.5, so you get 39.5. Similarly, if you have any other odd number like this, mostly it's two-digit numbers, but it works for three-digit numbers just the same way as well. If you have, for instance, 37 over 2, what do you do with this? You say, okay, let's break it down into two parts. 36 over 2 plus 1 over 2. What's 36 over 2? That's 18. Just put a 5 there after decimals, and that's 18.5. And that's the result that you're looking for. Okay, so division by 2, you will come across that again and again, over and over again. You should be able to do it like this. Okay. For instance, a very common type of problem that you will see would be like this. Find, for instance, a number, or let's do a fraction here first. Let's do a number. Find a number that is exactly halfway between 29 and 70. Okay. Find the number that is exactly halfway between 29 and 70. What does that mean? We are looking for the midpoint of 29 and 70, the middle value for 29 and 70. Whenever you have to find a number that is halfway between two given numbers, what you have to do is you find the average. How do you find average? Add the two numbers, 29 plus 70, and then divide by 2. And that will give you the number that's halfway between these two numbers. What's 29 plus 70? That is 99. So you have 99 over 2. Now, how do you do this division? You can say it's 98 over 2 plus 1 over 2. What's 98 over 2? 4 over 2 is 4. 8 over 2 is 4. And then 18 over 2 is 9. So 49.5. That's the result that you get from this. That's the number that's halfway between 49.5, halfway between 29 and 70, 49.5. So this division by 2 is going to come again and again. You should be familiar with this. Now, it's not only going to be for integers necessarily. Sometimes you are asked to find decimal numbers or fractions in problems like these as well. For instance, they might say, find the number that is, or they might say, find the number that is exactly between, yeah. So let's say you have 6.4 and 9.6 here. So you could have, you may be asked to do it for decimals like this as well. Now, the process remains the same. How do you find the number that is halfway between these two numbers? You find their average. This is going to be 6.4 plus 9.6. that is actually going to be an integer. Let's say it was not an integer. Let me make it 6.8. So it's slightly more difficult. Yeah, so now we will not get an integer. 6.8 plus 9.6 divided by 2, right? So you just add those two numbers and divide by 2. Now, first of all, how do you add them up together? You can do it on the side if you want. For addition, remember the decimals have to be aligned. 6.8 plus 9.6. What do you get from that? 8 plus 6 is 14. You get 4 here. And then 1 gets carried here. 7 and 9, that is 16. So this is 16.4. You've got 16.4 in the numerator. In the denominator, you've got 2. And now you need to do this division. 16.4. Now, if it was any other number, you would generally approach it like this, that you would multiply by 10 and multiply by 10, right? But with 2, it's simpler to do directly using the same idea that we used earlier as well. Divide 164 by 2, okay? So one way to think about this could be that you, okay, so that might make it easier for you to think of. Let's do it this way. 16.4 over 2, you could do it like this. 16.4, you do the same thing as we did in earlier examples. Multiply by 10, multiply by 10. Keep this 10 separate. In the numerator, you've got 164, and in the denominator, you've got 2 into 10. And then you can just think of dividing 164 by 2. How do you do that? 16 over 2 is 8, 4 over 2 is 2, that's 82 divided by 10, and that is 8.2. This is one way to think about this. Another way to think about this could be that you do it directly. And you say, okay, 1 over 2 you cannot do. 16 over 2, what's that? That is going to give you 8. And then you have a decimal after that. 4 over 2, that's 2. That can give you 8.2 directly, like this as well. That's the number that's halfway between these two numbers. Okay, now since we are on it, let's just consider one last example, because the same question a lot of times comes with fractions as well. So you should be able to deal with that too. So for instance, they might ask you to find the fraction that is halfway between 5 over 8 and, let's say, 2 over 16. Okay, so I'm going to give you 1 minute to think about this. Quickly tell me in the chat what it is going to be without using a calculator. Do not use a calculator for this. Do it without using a calculator quickly. Let me know what this is. Yeah, what do we get from this? What's the number halfway between these two numbers? Does anyone have the result? Mostly when they give such questions, they write the smaller number first and the larger number second, although that does not make any difference. But let's do it that way, because that's what they generally do. They write the smaller number and the first, and then the larger number next. It's the same thing. The process remains the same, but just so it's in the same format, we write it this way. Okay, find a fraction that's exactly halfway between these two numbers. Yeah, so how do we do this? You add these two numbers just like before and divide them by 2. So first of all, let's add these two numbers. 2 over 16 plus 5 over 8. Well, that's actually simple to do because 2 and 16, they could get cancelled. And that gives you 1 over 8 plus 5 over 8, and that's 6 over 8, which cancels out to give 3 over 4. So this is what you get when we add the two numbers. And then what you have to do is divide this by 2. Division by 2, that means, so it's like this essentially. 3 over 4 divided by 2. So that means 3 over 4 divided by 2 like this, and that's 3 over 4 times 2. That is, sorry, times 1 over 2. That's 3 over 8. Okay, now this is how you could think of this. Now you can, of course, skip a lot of these steps. Now this is me doing a lot of steps like this. You could do it quicker like this if you want. You could write whole thing in the same line. You could say, just add those two numbers, 2 over 16 plus 5 over 8. Just like before, we are adding the two numbers and then divide the whole thing by 2. Right? That's what we are essentially trying to do here. Now, how is this going to work? The numerators, when we add them up together, that gives us 1 and 8. And that gives us 6 over 8 in the numerator. In the denominator, we've got 10. Now we can write it separately if we want. It becomes 6 over 8 divided by 2. That is 6 over 8 multiplied by 1 over 2. That's how you'll be thinking of this in your head. You can do some cancellation here. That's 3. And you get 3 over 8 from that. So the idea is that you add the two numbers, divide them by 2, and then simplify your result. This is what we get from this. Okay, so what did we discuss today? How to add and subtract fractions. Okay, I wrote factors here earlier. How to add and subtract fractions by making the denominators the same. And then we talked about how to do multiplication and division for fractions. You only, so if you have an integer multiplying, please just multiply that with the numerator, not with both numerator and denominator. Just multiply that with the numerator. And then if you have a fraction over a fraction, so basically multiple fractions inside a fraction like this, how to deal with that? One idea is to write it separately like this and then convert it to a multiplication problem. Or you can remember these rules as well, that the denominators can go on the other side, go to the other side of the bigger fraction, right? So B here can go down, B can go up like this. That's what we discussed. We talked about the difference between proper and improper fractions, how to convert improper fractions to mixed fractions, how to convert mixed fractions to improper fractions. We talked about decimal addition, decimal subtraction, decimal multiplication, decimal division. And then finally, how to convert fractions to decimals by making sure that the denominators are 1 of 10, 1,000, 100, right? That makes it easier to do that division. And then division by 2 in particular, because that's extremely common. You should be able to do it very quickly in your head, how to divide any number by 2. So it'll either be an integer, if it's an even number, or you'll have a 0.5 with that. We discussed how to do it by separating out, putting 0.5 at the end with that number that you're getting. Okay, and then how to find a number that's halfway between two numbers. All right, so that's it for today. I will see you again next time, but before the next class, please make sure that you attempt as many questions as you can from the worksheet that I've uploaded so that we can discuss any problems that you have in tomorrow's class as well. Okay, that's it for today. I'll see you again in the next one. Love this. Bye.